This question is about a resolution of forces and a resultant force. In solving this question, I've relied heavily on visuals, that is, sketches. The aim of using sketches is to get you to understand the concept used in solving this type of question, rather than showing you how to write the answers on the answer sheet. I reason out that when you understand, then writing it down will just follow naturally. So by the end of the lesson, you should be able to do the following. You should be able to resolve a given force horizontally and vertically. You should be able to determine relevant angles on a diagram. You should be able to calculate the magnitude of each of the components. You should be able to determine the resultant force in a given direction, and you should be able to determine the resultant force acting on the object. So let's go straight to the question and read it through so that we can be able to understand what we are being asked to do. So in this question, we are told that three coplanar forces of magnitude 10 newtons, 10 newtons and 6 newtons act at a point P in the directions shown in the diagram. So the diagram is given here. There is the 10 Newton force, 10 Newton force, 6 Newton force, and the relevant angles have been given. PQ is the bisector of the angle between the two forces of magnitude 10 newtons. In other words, this one bisects this angle. To bisect is to divide it into two equal parts or equal sizes. So if this is 60, then this angle here is 30, and this angle here is 30. We are required to determine the component of the resultant of the three forces in the direction PQ and in the direction perpendicular to PQ. And then in part 2, we are required to find the magnitude of the resultant of the three forces. So let's go back to the diagram here. And in this diagram, we want to look at each force separately. That is, I want to look at this 10 Newton force separately from this one and also from this one. So let's move them aside so that we can study each on its own. So I've moved the 10 Newton force to this point so that I can get its horizontal component and its vertical component. Similarly, this 10 Newton force, I've moved it in this direction to get this component and this component. The 6 Newton force to this point, so this is 6 Newton force, I want to get this component and this component. And the components are as shown. So the horizontal components are given in blue, while the vertical components are given in red. Usually when we resolve a force in a certain direction, we make sure that the force itself always forms the hypotenuse of the rectangle, the force, so that the components will be these two sides, this side and this side. And by now you should know that when we resolve a force, we always resolve that force in two directions which are perpendicular to each other. For example, this force will be resolved vertically upwards and horizontally to the left. This 10 Newton force will be resolved vertically upwards and horizontally to the right, while the 6 Newton force will be resolved horizontally to the right and vertically downwards. It is very simple to understand this. The moment you take the force that you are resolving as the hypotenuse of a certain triangle, or alternatively, you can draw the rectangle with the force that is given being the hypotenuse of that rectangle. And then it's easy to get these two components. Now let's determine the various angles that we have on this diagram. And let's start with this 10 Newton force here. Now, this angle, we have already determined this angle to be 30 degrees. This one here to be 30 degrees. So when we moved this 10 Newton force to this point, that 30 degrees is actually this one here. Similarly, this 30 degrees here, so that the sum becomes 60, is the one which is here, 30 degrees. because it is the angle that the force makes with the vertical. Also here it is the angle that this 10 Newton force makes with the vertical. This, remember, this is the 10 Newton force. That one has not changed. This one is also the 10 Newton force, while this is a 6 Newton force. Now, since we have already determined this angle, we want to determine the angles here. Now let's look at this diagram. If this is 30 and this is 90, that makes a total of 120. This angle here will be 120 because it is 30 plus 90. If I extend this line like this, I know that the whole of this angle from here all the way to this point is 180. So, in order to get this angle will just be 60 degrees. So, I can write that one there as 60 degrees, this one here, or I can come here and I get my horizontal over here, and I will know that this angle again is 90 degrees, and since this is 60, this must be 30. So the angle that the 6 Newton force makes with the horizontal must be 30 degrees. So I come here and indicate that 30 degrees there. It's important that we get the angles straight. Now let's go to resolving of the forces. This 10 Newton force, if I were to resolve it in this direction, this will be 10 cos 30. This one here, 10 cos 30. And that will give us 8.660 newtons. This component here will be 10 sine 30. And this obviously will give us 5. Now when we come to this other diagram here, this obviously will also be 10 cos 30. It will be 8.660 newtons. And this will be 5 newtons. It's just as simple as that. On this diagram, this one will be 6 cos 30. And this one will be 5.196 newtons. This will be 6 sine 30, and that will be 3 newtons. So we've got the various components. We've resolved every force horizontally and vertically. It's either horizontally to the right or to the left, or vertically upwards or vertically downwards. Those are the two directions. Every time you're given a system like this, the first step is to try to resolve all the forces horizontally and vertically so that all of them form some kind of a plus sign. That ensures that the forces given are either exactly opposite each other or they are perpendicular to each other. This allows us to treat forces which are perpendicular to each other using Pythagoras theorem, and forces which are exactly opposite each other, we can be able to subtract the larger one from the smaller one, like we are going to see in the next visual. So over here, I have brought all the components now closer together so that they are back where the diagram was supposed to be. So let's remove that diagram so that at least we make it a little bit clearer. We had already seen that this one is 8.66 newtons. This is another 8.66 newtons. Well, this one was 5 newtons, and this is 5 newtons. This one was 5.196, while this is 3 newtons. So you can see we have removed the diagonal forces because for the 10 Newton force, which is this one, it is represented by this component and this component. This other 10 Newton force is represented by this component and this component, while the 6 Newton force is represented by this component and that component. So we can also get rid of these other diagrams here. So we now want to add them. First of all, we are going to add the forces which are in the same direction. Now, we realize that this one plus this one will be 8.66 plus another 8.66, because the idea is to try and arrange the forces head to tail, those which are acting in the same direction, like this. We've got our 5 Newton force and the 5 Newton force acting in opposite directions. And this one was 5.196. This is the 3 Newton force. This is 8.66 and this is 8.66. So the forces which are acting in exactly in the same direction, we put them head to tail in order to get some kind of resultant force in that direction. But we have not yet found the actual resultant force in the direction PQ as we were required. We are in the process of doing that. Now, the next step is to look at the forces which are in opposite direction and they are equal in magnitude. For example, this is 5 newtons and this is 5 newtons. And because they are in opposite directions, naturally the resultant between this force and this force will be 0. So the only force which will be left will be this one, the 5.196 force. Similarly, we will add this force and then subtract this one, as shown in the next visual. And this is what we get. So this force here will have a magnitude of 14.32. You can prove this one by yourself. You do 8.66 plus another 8.66 and then you subtract 3. You'll get 14.32 newtons. As already explained, this force here was 5.196. After the 5 newtons and the 5 newtons cancelled out, leaving the only component which was due to the 6 Newton force, the horizontal component of the 6 Newton force is the one which remained. Now we've got two forces which are exactly perpendicular to each other. You can see this angle is 90 degrees. When we want now to get the resultant, by the way, at this particular point, this will be the component in the vertical direction, in the direction PQ. So the answer to part A is this one here, 14.32 newtons. The resultant force in a direction which is perpendicular to PQ must be this one, and it is 5.196. And then in the last part, we are asked now to get the resultant force. In order to do that, we will connect these two forces head to tail. So we can either slide this one so that it comes here, or better still, slide this one and it comes here. When we do that, the tail of the red force will be connected to the head of the blue one. When you want to add forces, you must always connect them head to tail, so that after that you can use Pythagoras theorem to get the resultant. Now let's look at how that one looks like. And there you have it. We slide that force all the way here so that its tail is connected to the head of this one. So it's like you're moving from here, going here, and finally stopping here. But the resultant force now will be an arrow which starts from this point all the way to this other point here. Like that. That will be the resultant force. So remember, this is 14.32. This is 5.16 newtons. So in order to get the hypotenuse, which we shall call the resultant force F. So in order to get the resultant force, we shall do F squared is equals to 14.32 squared, that is this side squared, plus this side squared, 5.196 squared, and then in order to get f, I'll just do the square root of both sides. And when I do that, I will get a value of f equal to 15.2. 15.2 newtons. So you can see this question can be solved using sketches, and the reason why I like using sketches is that you get to see the relative magnitude of the force. You also get to see the direction in which they are acting. So practice on this, and you'll find that with some sufficient practice, and you'll get to understand how we resolve forces like we did with the 10 Newton force and the 6 Newton forces respectively.